Hello everyone. In this video, we will discuss about simple stresses. Okay. So alam natin that stress is equal to force over the area. So in this example, an aluminum tube is rigidly fastened between uh, bronze rod and steel rod as shown. So given the mga actual loads, so we have 20 kilonewton apply dito sa ating bronze going towards the right. Then meron tayong 15 kilonewton dito, another 15 kilonewton here, and 10 kilonewton dito sa dulo ng steel. Okay, so given lahat ng cross-sectional area in terms of millimeter squared, so ang hinahanap are the stress uh, in each material. Okay, so given all the area, so kailangan lang natin ma-determine yung mga forces to get the stresses. Okay. So, ang gagawin lang naman natin is to get the internal forces for each material. So, ang gagawin lang naman natin to determine the internal forces is to cut or get a section for each material. So, simulan natin sa bronze. So, magkakaroon tayo ng cutting section dito, no? Then, if we isolate yung, ito, drawing lang natin. Isolate natin or kunin natin yung free body diagram nung na-cut natin na section. So, let's say ito yung bronze. Okay, so given yung area. Then, ang applied load is 20 kilonewton. Okay. Then, yung internal force acting dito sa ating bronze is obviously will be pointing towards the opposite direction. Okay, so tawagin natin tong force P sub B para sa bronze. Okay, then so obviously if we sum up forces along the horizontal, and that should be equal to 0 dahil equilibrium tayo, then minsan na yung 20 kilonewton minus ng force B, actual force PB. Okay, then that should be equal to 0, then yung force PB is equal to 20 kilonewton. Okay, then solving for stress. Okay, so stress sa bronze is equal to pwedeng ano, no? So yung units natin kasi anong unit nung stress na gagamitin. So kung gagamitin natin yung 20 kilonewton, kasi di ba stress normally is in Pascal or kilopascal or megapascal and even gigapascal. So Pascal is if all of these units are in terms of per meter squared, then this is Newton per meter squared. Kilopascal is kilo Newton per meter squared. Megapascal is mega Newton per meter squared. Gigapascal is, of course, giganewton per meter squared. Pero yung megapascal is also equivalent sa Newton per millimeter squared. Okay? So, kung may specific na unit ng stress na required, then of course yun yung gawin nating output. So, kung gusto natin naka kilopascal, then that should be in kilonewton per meter squared. And sabihin yung ating cross-sectional area na naka-millimeter squared should be converted to meter squared. Okay? So, i-move ko lang to. Okay. So, 20 kilonewton over 700 millimeter squared. So, convert natin yung millimeter squared sa meter squared. So, gusto natin makancel itong millimeters na nasa denominator. Then, lagay ko dito yung millimeter sa numerator. Okay? Then, millimeter to meter. And for every 1 meter, meron tayong 1,000 millimeters. Okay? Then, naka-square yung area. Then, naka-square din dapat tong ating conversion factor. Okay? Then, we will have 20 times 1,000 squared, then divided by 700. Okay? So, makakancel out tong millimeter squared. Then, yung stress sa bronze is equal to 28,571.4. This is kilo Pascal. Okay? So, kilonewton per meter squared is kilopascal. So, this is also equivalent if i-convert natin siya sa megapascal. So, alam naman natin na so, gagawin natin megapascal. Lagay natin dito yung kilopascal. Then, for every 1 megapascal, we have 1,000 kilopascal. Okay? Then, makukuha natin yung 28.571 for megapascal. So, pwede rin namang ganito. So, yung megapascal nga is equivalent sa Newton per millimeter squared. Then, solving again for stress at bronze, sa material nating bronze. So, yung force na 20 kilonewton, so i-convert ko na lang siya sa Newton. So, kilo means 1,000. So, we have 20,000 Newton per or over 700 millimeter squared. And again, Newton per millimeter squared is megapascal. Okay? So, 20,000 Newton over 700. Okay? So, same stress, 28.5714 megapascal. Okay, so madali lang yun sa may bronze. Then let's proceed sa aluminum. Okay, so once again, i-cut natin dito yung aluminum. Then let's draw the free body diagram. Okay. So para sa aluminum. So draw lang muna natin. Okay, so we have 20 kilonewton dito. And dito naman meron tayong 15 kilonewton. Okay. Then, we need to determine yung actual force or yung internal force sa aluminum. Tawagin natin siyang P sub A. Okay. So, in this figure, obvious na for us to have an equilibrium, so yung direction ng PA should be towards the left. Okay? Pero kung masyadong complicated yung mga given na forces, masyadong marami, then you can always assume yung direction. Then if that becomes positive, then tama yung assumption mo ng direction. Then kung mag-negative, so your assumption is opposite in direction. Okay? So um let's sum up yung forces again. Forces along the horizontal. So we have 20 kilonewton if we take um, right direction towards right to be positive. Then 20 kilonewton is positive. Then minus no 15 kilonewton. Then minus no. So in-assume natin na towards left yung force PA. And then minus P sub A. Then that should be equal to 0. So, i-rearrange lang naman natin, then makukuha natin na P sub A is equal to 5 kilonewton. Okay? Then, solving for stress. So, gawin na rin natin naka-megapascal. Okay, so again, megapascal, gagamitin ko itong ganitong unit. Paano ba naging equivalent ang megapascal sa Newton per millimeter squared? Okay, so isingit lang natin. Okay. So if we have yung 1 megapascal, again is mega Newton, okay, per meter squared. So kung i-convert natin to sa Newton per millimeter, then, so unahin ko muna yung Newton. So, Newton, then over mega Newton, para makancel natin yung unit na mega Newton. Okay, so this is 1 megapascal. So, mega is times 10 raised to 6. Okay, so, di ba, kilo, mega, giga. So, kilo is times 10 raised to 3. Mega is times 10 raised to 6. Giga is times 10 raised to 9. Okay, so for every 1 meganewton, so we have 1 times 10 raised to 6 Newton or 1 million Newton. Okay. Then next, convert natin yung meter sa millimeter squared. Okay. So, meter sa denominator. So, dapat may meter tayo sa numerator dito sa conversion factor. And from meter, gawin natin siyang millimeter. And for every 1 meter, we have 1,000 millimeter. And naka-square dahil area. So, square din natin yung ating conversion factor. Okay? So, kung i-solve natin yan, 1 times 1 times 10 raised to 6. Okay, then divided by 1,000 squared. So, actually, equivalent naman to eh. 1 times 10 raised to 6 saka yung 1,000 squared. Okay. Yan. So, equal pa rin sa 1. So, that will be equal to 1. So, cancel yung meter squared, cancel to. Then, 1 Newton per millimeter squared. Okay? So, balik tayo dito. So, solving for, again, stress at the aluminum. Okay, then we have yung 5 kilonewton, gawin natin newton. So, multiplied by 1,000 lang. So, we have 5,000 newton per. So, given naman yung area na 1,000 millimeter squared. Okay, then stress at the aluminum is So, yun. 5. So, 5 megapascal. Okay? Then, lastly, yung ating steel. So, dito sa steel, pwede tayong mag-cut. First, ika-cut natin to. Kuha tayo ng section line. So, pwede natin consider yung buong system sa left side or mas simple kung dito lang tayo sa right side. Pero let's compare kung ano yung makukuha nating actual force, internal force dun sa steel. If we compare yung dalawang side. No? Okay? So, dito na lang. So, meron tayong bronze. We have aluminum. Yung ating steel. So, we have 20 kilonewton, 15 kilonewton, so another 15 dito. Okay. Then, okay. So, mas malaki yung mga forces going left as compared dun sa force na going right. Then, kulang tayo ng force going to the right. Okay. So, tawagin natin tong P sub S, actual force ng steel. Okay, then if we take the summation of forces along the horizontal, so we have 20 kilonewton minus 15 kilonewton minus another 15. Okay, then plus, dahil going right, consider natin positive, P sub S, then that is equal to 0. So kung isa-solve natin yan, then we will have P sub S is equal to 10 kilonewton. So, since positive ang lumabas, then tama yung assumption natin ng direction. So, if we take naman by the way, yung force natin, this na PB, so this is compression. Compression. Yan. Kasi patulak siya, di ba? Patulak siya dun sa, ano natin, sa material. Then, dito sa aluminum, this is also compression. Okay? So, patulak din sa ating member. Then, tension naman tayo dito sa P sub S. Okay. So, if we take the free body diagram ng steel on the right side, then ito yung makikita natin. No? Okay, so meron tayong 10 kilonewton and so obviously yung ating internal force PS will be acting towards the opposite direction. And mapapansin natin dito sa free body diagram na tension pa rin yung makukuha nating actual force. So pahila pa rin siya dun sa section ng steel. Okay? Then dalawang force lang naman yan. Then obviously P sub S is equal to 10 kilonewton. Still, tension pa rin tayo. Okay? Then solving for stress. Okay, so solving for stress, then we have 10 kilonewton is 10,000 newton over. So given yung area niya na 800. millimeter squared. Okay, so 10,000 divided by 800. So we have 12.5 megapascal. Okay? So madali lang tong ano no, madali lang tong example natin na to kasi stresses lang naman for each material. Okay? Pero on our next example, doble siya dun. Delete ko lang. Okay. So dito sa next example natin, so meron pa rin tayong aluminum given yung area na 200 millimeters squared. Then we have steel pa rin with an area of cross-sectional area na 400 millimeters squared. And bronze again with 500 millimeters squared. Okay. So is steel tube is rigidly attached between aluminum and bronze. Okay. So halos similar lang yung sa kanina, no? And given nga yung mga actual forces as shown. So find the maximum value of P that will not exceed stress in aluminum. So given yung mga allowable stresses nila, no? So 80 para sa aluminum. Sulat natin dito. 80 megapascal. Then steel is 150 megapascal. And in bronze, so we have 100 megapascal. Okay. So ano daw yung maximum value ng P? So anong approach ang gagawin natin? So we need to determine pa rin ano yung magnitude ng actual force, okay, doon sa bawat material natin. Okay? Then doon based dun sa mga actual forces nila, merong allowable, okay, given yung mga allowable, then we can solve for the value of P. Then of course, yung maximum value ng force P na hindi mag-exceed yung kahit alin doon sa mga material natin, doon sa mga allowable stresses, will be the least value na makukompute natin. Okay? So, kunin muna natin yung mga forces. Okay? So, we will cut again dito sa may aluminum. Okay? Then, drawing lang natin para mas malinaw. Okay? So, meron tayong force P. Okay, then, of course, yung internal reaction will be yung P sub B or P sub A, aluminum. And we can say na PA, actual force PA is equal to the force P. Okay? Then sa steel, if ikakat natin to dito, okay, so we have force P. Then dito meron tayong 3P. Okay, so mas malaki yung papuntang left, then expect natin na yung internal reaction natin will be towards the right. Okay, then tawagin natin itong force P sub S. Okay, so actual force in steel. Then, if we sum up yung ating mga forces again along the horizontal. So we have P minus 3p, okay, then plus p sub s is equal to 0, then p sub s is, so magpa-positive to, pag tinrounds po sa kabilang side, magni-negative to, so 3 minus 2, 3 minus 1 is 2p, okay? Then lastly, sa bronze, sukat tayo dito. Okay. So, mga forces natin, P, 3P, and then meron tayo ditong 2P. Okay? So, assume ko na ito yung direction ng um, internal force P sub B para sa bronze. Okay? Then, again, summation of forces horizontal to be equal to 0. Okay, then we have force P minus 3P. Ito, kaliwa. Minus 2P. So, negative minus ulit dahil going left again yung 2P. Then, plus P sub B. And this is equal to 0. Okay? Then, negative 5. Pag tinaspose, magpa-positive 5. Then, magma-minus to, minus P. So, we have 4P. Okay? Para sa PB. So, given the stresses, so ang hinahanap natin ngayon is yung value ng P. So, again, stress is equal to force over area. So, solving for force, then that is yung ating stress times the area. Okay? So, yung force F, so yun yung actual force P. Okay. So, yung force dun sa ating aluminum is P sub A, which is equivalent sa P. Then yung stress natin na 80 megapascal. Stress is force, so force P over area na 200 millimeters squared. Okay? Then force P, yung allowable force P sa aluminum natin will be, so 80 megapascal times 200 millimeters squared. So we have 16,000 Newton. Okay? So, paano naging Newton? Kasi itong ang megapascal is Newton. Ibahin ko lang yung kulay. Ito, no? Is Newton per millimeter squared. Okay? So, makakancel lang itong millimeter squared. Then, may iwan na force is in Newton. Okay? So, that is yung allowable value ng P in terms of yung limit natin ng stress sa aluminum. So, let's proceed dito sa steel. Okay? So, again, yung stress allowable is, given doon? 150. Okay? So, Newton per millimeter squared or megapascal. Then, this is equal to yung force over area. So, yung force natin is 2P. Okay? Ito. Over ng cross-sectional area na 400 mm squared. Okay? So, we can cancel na yung over millimeter squared sa magkabilang side, no? Then, over millimeter squared din dito. Okay, then, yung force P, considering yung limit natin, si stress is still, is 75. Okay. Ay, may 400 pa pala doon. So, 150 times 400 kapag transpose natin yung area, then divided by 2. Okay? Tama, no? So, itataas lang naman natin to doon. So, kaya magiging 150 times 400. Then, ito naman is matatranspose papunta doon sa denominator. Then, over 2. So, we have 30,000 Newton. Okay? And then, lastly, sa bronze. So, yung allowable stress natin is 100 megapascal or Newton per millimeter squared. Then, this is equal to force over area. Ang force natin is 4P over yung area na 500 millimeter squared. Okay? So, on both sides, meron tayong per millimeter squared. So, we can cancel that unit. So, may iwan sa atin is yung Newton. Okay? So, 100 times 500 then divided by 4. Okay, so again, pag nag-transpose tayo, yung 500 mamumultiply sa 100 times 500 then ito mata-transpose papuntang denominator then over 4. Okay, then yung value ng P is 12,500 Newton. Okay, so again, ang question is, what is the maximum value of P? So, para hindi tayo mag-exceed dun sa allowable stress ng lahat ng materials natin. Then, of course, if gagamitin mo yung 3,000, i-apply mo tong 3,000 dito sa bronze natin, then yung stress natin will be much greater than sa allowable na 100. So, ganun din kung gagamitin mo tong 16,000 Newton. And yung final answer natin will be etong smallest doon sa mga na-compute natin, no? Okay? Which is 12,500 Newton. Okay? So, that is our example dito sa simple stress. So, sa ngayon, ito lang muna, no? Then, try kong hanapan ng oras pa to add more examples discussion dito sa aking channel. Okay. So, again, that's it for tonight. If nagustuhan nyo yung video, so please subscribe and share nyo na rin sa mga classmates nyo. So, para mas maraming baka naman makatulong kahit paano. Okay? Again, so see you on my next video. Little